Greetings and welcome to the CDC Experience podcast series. I'm your host, Will Crawford from the Real Estate Department here at the CDC of Tampa, where I'm the Acquisition and Special Projects Manager. For this installment of the CDC Experience, we will be discussing some exciting things that we have going on in the real estate department. I have a special guest that will be joining me to discuss 3D construction printing and how this new technology will be having an impact on the CDC, East Tampa, and Hillsborough County. So, just to give a little background, some folks in the area may know the CDC was the recipient of some grant funding from Hillsborough County to purchase a 3D construction printer to help us continue our mission of building affordable homes in the area. During the COVID pandemic, there was a sharp increase in the cost of building materials that started to affect the cost of building across the country as supply couldn't meet demand. So, for example, some people may have seen the ships backed up for months, the ships bringing in all these supplies. Actually, there was a point in which the cost of wood was more than the cost of gold. So, homes were building around $100 per square foot or less during that time, and then all of a sudden they were priced at $150 and up. And it doesn't seem like a lot of money, but if you take that extra 50 and you multiply it times 1,300, which is the average size of a small 3-bed, 2-bath home in the area, you'll see that's an additional $65,000. Um, so it made it real hard to continue to do the stellar work that the organization had been doing. And from an affordable housing perspective, I mean, it was tough. It was tough to really get people qualified people into homes, and this is the kind of work that the organization has been doing for over 30 years. And so, as an organization, we started exploring other options like container homes. We looked into panelized modular builds as well as prefabricated builds. Um, One other technology that really made an impression on us was 3D construction printing. Now, the first time I saw a YouTube video about 3D printing, I was totally blown away. I mean, I just the fact that you could print a house just totally blew me away. That started me on a personal mission to learn all I could about the technology and its benefits. The first permitted 3D house in Florida is in Tallahassee, Florida, and I visited that project multiple times. And I went into a deep dive on the technology, the manufacturers, materials, and this led me on a path to our guest today, who is one of the brightest minds in this field, Mr. Fernando Paolillo, who's owner of ProBuild 3D, and they're a 3D printer manufacturer. Fernando is a pioneer in the field of 3D construction printing, and his company is partnering with CDC to help us on our journey with 3D printing homes and other structures as well. Fernando, how are you?
Doing well, Will. What about yourself? All good?
Doing well, doing well, doing
Awesome.
well. So tell us a little bit about your background and how you ended up in this field with this technology.
Sure. Well, first of all, I am an engineer, so I'm always looking at new inventions and new stuff and new businesses and models, right? I am a mechatronics engineer, so basically, robotics and electronics and mechanics, right? I'm from Brazil, so I'm living here in the United States since 2009, 2010. Used to work for big corporations, so my background is the automotive industry, aerospace industry, right? I had the chance to work for companies like Volkswagen, Audi, Lamborghini, Porsche, right? Eaton Corporation, and so on and so forth. And around 2013, I started to work with 3D printing, multiple materials, multiple platforms, right? And in 2017, we started to really deep into this construction 3D printing, the knowledge and skills and equipment in the market, what is really needed. And then I fall in love for that because I agree with you, it's a really interesting technology. If you look at the way the automotive industry, the aerospace industry evolved, right, in the last 50 years compared to construction, you see that we have opportunities, right, in the construction with, the use of new technologies, automation, productivity overall, right? There's a huge benefit of really leveraging, especially technology more. than what we are doing. Of course, I'm not talking about big construction companies that are building, infrastructure, big stuff. I'm talking about home construction. I think we have really a huge gap there in terms of technology and also manufacturing mindset, right? Because at the end of the day, when you are putting a house together, you are manufacturing the house, right? So we have a lot of concepts that we can bring from manufacturing, automotive, aerospace, that we can definitely apply in construction. And they started everything is with 3D printing, in our opinion, right?
So, for someone that is totally new to the industry, how would you explain what 3D construction printing is?
Okay. So first of all, it's a very simple process if you think about it, right? So you have a design in the computer in 3D, right? Then you get this design and you use a machine to layer by layer translate this digital mockup into a real object, right? So 3D printing basically is a process where you pick the material in a design and then you slice this 3D object into layers, right? And you can of course define how thick is the layer height, and all those parameters, right? Um, so after you do that slicing in the computer, you connect to an equipment that is a kind of 3D printer, like the one that we use for plastic or for metal or for any other type of material. And this equipment will start to build this object, in our case, a house or a shed or an object for whatever you may be aiming to, layer by layer. So it's going to start to build the object, right? Layer by layer. And suddenly you see the real deal in front of you very fast. There is no need to do molding or to have multiple, people involved. It's just a process of. It's very the lead time from a design to a final object is amazing, and that's why 3D printing was really a revolution, right? In aerospace, in automotive, and the medical industry, right? And so on and so forth. So easy, right, for you to go from a design to an object. But basically, this is what 3D printing is. And in our case, we are using cementitious material to,
That was actually going to be my next
yeah,
question. What is the material that you're using?
right. Yeah, we use cementitious material. They look like concrete, right? The texture of a concrete is a paste, right? So the printer will basically you're gonna have a pump, right? That's gonna be pumping the material through a hose system, right, to the nozzle of the printer, and then this printer will be depositing that cementitious material into those layers, right? The tricky thing is the material should be cure enough to sustain the layers on top, but it should be still wet enough to bond, right? To have this bond between the layers. So that's the critical part regarding the material in the process. So you have a lot of things that you need to think about, right? The speed that you're printing, the size of the nozzle, the size of the project, how much time is going to take for you to build one layer on top of the other, because a cementitious material is a material that is a kind of paste, right? So if you go too fast, you don't give enough time for the material to cure, and everything is going to collapse. And if you go too slow, the next layers are not going to bond to the previous layers. So it's a kind of math that you need to do there, but it's not that.
So, you talked about time. What is the time to build for the types of homes that we produce? 3 bedroom, 2 bath, 13, 14, 1,200 square foot homes.
Right. Yeah. So this varies a lot. It's going to depend on the printer that you're using, the material that you're using, right? How many printers you're using, because there are technologies out there like ours that you can use multiple printers at the same time, right? So imagine that you can have 3 or 4 printers working simultaneously, right? So definitely you can build a house in less than one day for sure, 3D print a house. But just to give you a perspective, in average, the printers in the market are printing anywhere between 80 millimeters per second, right? That's I know millimeters is not so useful, so known for us, but it's the metric that 3D printing uses worldwide, right? So um, 80 millimeters per second, which is 8 centimeters, is like a half inch, a little more, right? Sorry, a half feet or more, like this, right? And then all the way to 120 millimeters per second, right? That's the average speed of 3D printing, right? Within that speed, 120 millimeters per second, with one Pro Build printer, for instance, you can build a house in 1 day and a half. 3D print the house in 1 day and a half, right? In a average design, right? A double wall, right? Because usually the walls are hollow, so you need to print one side and the other side of the wall. So you have a space in the middle where you do electrical, plumbing, right? Very easily. So to print a house with this design at 120 millimeters per second, it's going to be an average of 1 day and a half of printing. In other words, 12 hours of 3D printing. Of course, if you have a journey of, let's say, 6 hours a day, right? You just stop, clean the equipment, people go home, and then they come back next day. So this could take you 3 days, 4 days, or even 1 day and a half. If you go, you know, um, 12 hours, you can just do it, right, and finish. Just a quick reminder, right? The material should support that. You will see videos out there, to your point, of constructions, permitted, not permitted, that especially with the big printers, that they print the first layers and they can go like 1 foot tall max to 1.5 foot tall per day, right? And then they need to stop. First, because the day is over, right? So people need to go home. Journeys, the working hours are over. And second, because the material will not sustain more layers. They are afraid of, the wall to collapse. You can imagine all the stress on that, right? So they stop, they wait, and then they keep going after that next day. In other words, in average, we are seeing people printing homes in 2 to 3 weeks uh, time frame.
Now, what are the benefits of a 3D printed home versus a traditional home?
Hmm. Well, um, here in America, right? We have imagine an external wall, right? So you have the cinder blocks, right, that you need to put together, and then inside you do the wood framing, usually, or metal framing. Usually it's wood framing, as you know, right? And then you do all the insulation and plumbing, electrical, and it's really messy usually, right? You need to drill and all this stuff. It's so messy that then we come with the drywall to cover everything, right? Looks beautiful now, right? And we cover everything, and then you're ready to finish and paint, and you have the wall ready. Outside, you do the stucco, right? You do the stucco, and then you paint, right? A 3D printed wall, you don't need to do anything like that. You just 3D print, it's hollow. If you want to cover the layers, you can do stucco inside and outside. The wall is ready to go. Advantages of those walls, right? Lead time, definitely. Cost, because you don't need to do framing, drywall, anything like that. Now, resistance. The materials that we use for 3D printing, they are very resistant, very strong, right? So let me give an example. A cinder block has a resistance of, let's say, 9 MPa. MPa is a unit, right? That we are measuring pressure, right? 9 MPa, 8 MPa. The 3D printing material is around 49 MPa, right? So it's much stronger. So what is well, so why? So what, right? The wall is going to be much more resistant. So to give you an idea, we have ballistics tests in some walls, and the wall is bulletproof in some cases, right? With a 1 inch layer like this, right? No termites, fire resistant, water resistant, right? Strong. So this is gonna give you maintenance wise, gonna be really easy for you to take care of those walls. If you want to put a TV on the wall, right? We are always afraid, right, to play around with the the drywall. Those walls, you go with a drill. There is no nail and a hammer, right? No way. You need to go with a drill. You drill and you put the. You can put a 200 inches TV on the wall, no problem. It's going to be very, very
So
resistant,
you don't
right?
have to worry about finding the stud in the 3D printed wall.
No, no studs, exactly, right? So you're going to be always fine, and it's a pretty. We believe also insurance over time is going to be lower because imagine from an insurance company standpoint, right? You're insuring a house that has walls that are waterproof or water resistant, a minimum, fireproof, fire resistant, right? Um, I mean, no termites. So those are basically the advantages, right, of this kind of thing. And the lead time, of course, right?
Now, I was reading something about the energy efficiency
Right.
of 3D printed homes. Is that
Yeah,
something you're seeing in your designs and some of the tests that you've been doing in some of your builds?
yeah. Um, Energy efficient, it depends also in your design, right? How you design the wall. So, but it's a good point. For instance, if you have a wall, imagine a wall that is 10 inches thick, right? And then you have a layer of printer, 3D printed here, 3D printed here. And then you have it's hollow, right? So you have air in between, right? As a traditional wall, you can put some insulation here, whatever insulation you may want, right? And you have excellent insulation, excellent sound proof as well, right? So definitely, if you have a good design, right, 3D printed, you're gonna have amazing energy efficiency in those homes, right? Uh, Considering that you're using the right windows, right, doors, as you know, those are very important points for energy efficiency. And in the roof, right, that is another point. You should have a really good insulation on the roof as well. Basically, your house is going to be a banker of concrete, right? That brings us to another big advantage, especially here in Florida, right? Hurricanes and tornadoes,
Right, right.
wind, right? Those walls are, remember, bulletproof, right? Depending on the material used, of course. Majority of them are pretty resistant.
Now, when I stumbled upon 3D printing, I remember seeing some YouTube videos, and there were these huge machines, but then there were also some smaller machines as well. So, what are the different types
Yeah.
of printers?
So basically, we have three types of printers in the market today, right? One is called a gantry printer, which is basically everybody that is used to a plastic or a polymer 3D printer, right? That's the plastic one. Is like exactly that. It's a gantry, right? That, but it's big. It should be bigger than your project, right? So again, three is the first one. So basically, you have columns, four or six columns, usually made out of steel, stainless steel, aluminum, right? And then you have this whole gantry structure on top, should be taller than your project and bigger than your lots, if you will, right? Or not really the lots, the area that you're gonna have the the house itself, right? The blueprint. Um, that's the first kind of printer you see in the market. They are very big. They are difficult to move around. You can imagine setup time, right? For you to assemble everything takes quite a bit of time. Requires very specialized labor to do it, right? and the lot or the foundation of the where you're going to print should be very well leveled, right? Because this printer really requires a strong foundation because it's pretty heavy, and also requires very well leveling, right, of the lot. That's the first type of printer. Very common out there. You see a lot of gantry printers, right? Um, the second one is what we call robotic arms, right? So it's basically an industrial robotic arm, like the ones that we use in the automotive industry or whatever, that it was adapted to 3D print, right? So those robotic arms are connected to a base that can move sometimes or stay put in a place, right? And then this robotic arm will deposit the material around itself. Usually in front of the robotic arm. It's difficult for you to see robotic arms that are capable to do 360, right? And I will get to ours in a second and why we got that design, right? And the third one is called Delta, right? Or you also have in that category semi-gantry, which is basically a printer, two models, right? One is it looks like a spider in a structure like a gantry, and this head is going to print inside. It's very similar to a gantry. Now the semi-gantry usually has two conveyors and the head that it's going to be in a structure moving back and forth, right? These printers also should be bigger than the project, right? And those printers usually are very difficult to set up and move around and transport, etc. Okay. Um, let's talk a little bit about the printers that we are using, right? It's the CNC, the ProBuild printers. We design a robotic arm is not an adapted robotic arm, right? So we designed from scratch here in Florida, right? A robotic arm that is simplified. It's called SCARA robotic arm. So it's like a human arm, right? So you have the parts of the arm and right, very simplified. Um, very strong material. It's all aluminum. And this robotic arm that is customized to 3D print, right? It is designed to 3D print, moves on top of a rail, one single rail, right? And with that, you can print 360 degrees, right? Both sides of the rail. And that's the design that we came across in 2018 to simplify the 3D construction process. Because at the end of the day, you need something that is easy to move around, easy to set up, easy to operate, right? And at the end of the day, the construction day, it's going to be easy for you to disassemble, put aside, right? Or do whatever you want, or keep printing. It depends, right? Um, so those are basically the printers. To be straightforward or to in a nutshell, the big gantry printers are for big projects that you're gonna go multiple floors, maybe, right? Like a black buffalo of life, right? That you go multiple floors, complicated. It's gonna take you a lot of time to do it. So maybe it's worth it the time to set up the machine and put the machine together. And the robotic arms, like scars or the robotic arms, are more flexible, right? And you can do indoors, outdoor print, whatever. So basically, that's it.
So, Fernando, why is this not a fad? What is the future of this
Mm.
technology, and why is it here to stay?
Well, I think this technology is going to evolve a lot in the next 5 years. We ourselves are already developing the new model, Um, but let me give you some insights of what I believe is the future, right? First of all, multiple heads printing at the same time.
Okay.
Think about it. You put together a gantry printer, gigantic structure, right?
Mm-hmm.
A lot of work there. But at the end of the day, you have one extruder doing all the job, all the work, right? Okay. Future, multiple heads. And we are working towards that, right? This is our vision. We want to have multiple robotic arms, multiple heads working in parallel, accelerating the construction and bringing the lead time to less than 1 day, no matter what type of construction you're talking about. I think
Okay.
machine vision is going to be also incorporated, like a vision in a way that the machine will know if everything is okay or not, right?
Hmm.
If the layer is the right, uh, uh, let's say, height or whatever, right? And it's going to fix itself, right? It's going to slow down the
Really?
pump or accelerate the pump depending on how it's going on, what's going on. It's a feedback loop. I think machine vision is going to be incorporated not only to have a quick video of what's going on and somebody looking, but the machine will be intelligent enough to fix itself, right?
Hmm.
And again, pump more material, pump less material, or even stop, right?
Yeah.
Something is going on that it's so bad that let me stop. And then human beings will come and do something about it, right? So machine vision, artificial intelligence, right?
Hmm.
Um, Let me give an example. I think the printers will know where they are, right? Imagine that you have a slab and we give some points as reference for the machine. The machine will
Right.
come to the construction site, literally, right? And
Hmm.
we'll know this is this corner, this is that corner. It will start to 3D print by itself. No need to align, no need to do anything. So those are three of the things that I believe we're going to see in near future, actually, in
Okay.
construction 3D printing.
Exciting. So tell me about this software that's making all this happen.
Basically, for you to do construction 3D printer or 3D printing, you need two types of softwares, basically, right? One is a 3D design software. Any software that does 3D design, right? We're talking about AutoCAD, SketchUp, Rhino, it doesn't matter, right? So one software to do the 3D design, okay? That's the first step. Once you have the software to do the 3D design, you export this design in a special format, file format called STL. Usually that's the one that we use. And another software will come now into the equation. It's called a slicer. So it's a software that will get this 3D design, and based on parameters that you set in the software, we will slice this 3D object, right, for you. And we will translate this into another file that the machines can read. That is called a G code, right? By the way,
Eco.
CNC machines that we see a lot in the industry, they also read G codes. It's the same thing. So a
Hmm.
mill, lathe, or CNC machines, they usually read G codes, right? So you need a software to do the slicer, right? In our case, we are working with commercial softwares, open source softwares for slicing, right? So Cura, Simplify 3D, or you can go a little fancier and work with a combination of what we call Grasshopper and Rhino, right? And then
Hmm.
you have control of acceleration of the machine. It's much more fancy, right? But
Right.
those at the end of the day are just slicing the object. That's what they do. And the 3D design, honestly, you can use whatever software you are used to design. AutoCAD is pretty famous, right? SketchUp, those kind of softwares.
Okay. So your company decided to make your software open source. I know that when we were
Mhm.
looking at other companies, there was like a cost associated with the software that you had to have for the machine, and there was an annual fee or something like that.
Right,
But you guys decided to make your software open source and free.
exactly. Use a platform. Why open source, right? Because we are not slicer experts, right? Those guys are, right? And open source means they always have updates, right? They're going to be incorporating new technology all the time. The future, to your point, in the future, slicers are going to be much more agile, fast. precise, right? Because this is all they do. They develop slicers, right? So we said, you know what? We need to have our profiles of our machines on those softwares, right? Because we are going to evolve with the top-notch technology we see out there around, uh, slicer uh, softwares. That's why we decided to do it. We are developing another thing. Keep in mind that if you are operating a robotic arm, right, a robotic arm for real, it's you can't use those softwares. It's not the same. You need to have a robotic interface, right? And you need to do a lot of coding by hand, right? G code by hand and things like that. It's not super complicated, but requires a certain knowledge of software development languages like C++, things like that. If you have that basic knowledge, G code, right, you can do it, but you need that special person doing it, right? um, yeah, and finally, when we developed our solution, we were thinking about all the problems that we were seeing, right, in the market. First, software should be easy for the final user, right? So you will be capable to slice an object and 3D print it, and then you look at the object. Oh crap! This is not exactly what I wanted. So very easily you can go ahead and slice again and print again, right? Because the software is easy to use. In a scenario where you're using robotic arms or specialized software, that's not that fast at all. You need to have this specialist, slicing for you and doing all this stuff, right? So another thing, Wi-Fi connection. So our machines, you connect with the machine via Wi-Fi. The machines, they broadcast their own Wi-Fi, and the interface of the machine is 100% online. What this mean? You don't need to install anything. You can use your cell phone, open your browser, right, and connect to the machine. So you need softwares that are light, that are not heavy, right? So that's the path that we decided to move towards. Simple, easy, and uh, softwares that are everybody knows, right? How to use. Yeah.
Last question before I let you go, Fernando. How many people does it take to build a house with your machine or some of the other machines in the industry?
Yeah. So one printer. So basically, you have two workstations, if you when you are 3D printing, right? One is this operator that is starting the software, starting the printer, and observing everything and checking everything and calibrating everything, right? And the other one is responsible for the material, right? So we are trying to simplify this as much as we can. Let me tell you why and how, right? You need to mix the material, right? It's a cement. So you have the dry mix and then water. So you have two ways of doing it: batches or continuous mix, right? So we design a continuous mix that you just keep the hopper full of drying mix, and you set up digitally amount of water and amount of powder in this case, and this continuous mix is going to keep mixing material in a very consistent way. This mix then is going to go into the pump, and the pump will be pumping through the hose, right? And then you have the material being deposited right on the other side. The printer is printing. So you need a person to just look at all of this stuff and keep the mix full. Check if the water is okay, right? Bring more material if necessary. If you have a silo, right, it's going to be probably once a day. If you're decided for whatever reason to use bags, you need someone to bring bags, right? So that's one person, and the other one is the computer, the person that is checking the print, that is doing that. Remember, I was talking about the machine vision, checking if layers are looking good. So for now, we still need that person. But as soon as we start to install artificial intelligence and machine vision, you're going to need one operator to run the machine, and that's it. That's all you need. And if you have two printers, let's say you have a printer operating one side and another printer operating one side, right? You're going to need probably three instead of four because the material guy can take care of the two machines, and then you have one operator for one machine and another operator for the other machine. Right? A lot of people will say, "Oh, you are killing jobs." No, absolutely not. First of all, nobody thinks about ergonomics, right? Carrying cinder blocks and doing some of what they call the brick work, that thing, you break people with that, you know. So ergonomics is a big problem in construction, right? So yeah, I agree that for the wall, you don't need a lot of people carrying blocks all over the place and doing all of those crazy jobs, right? We are evolving that job into a person that's going to be operating the machine. And to your point, you're going to need people to do finishing, the slab, the roof, all the painting job, and et cetera, et cetera, et cetera. So a lot of labor involved there after doing the wall. But the good news is at least for you to put together um, the shell, it's going to be much easier, much faster, and much more and safer, right? Much more safe for people to do it. There is a new method now with panels, and there is another one with metal, recycled metal panels. Very interesting. You can do that. We call those hybrid homes, right? That you have only the external walls 3D printed and internal with something else. Now you can do external walls 3D printed and internal walls using 3D printed modules, right? So you 3D print the modules and you install the walls. So yeah, the possibilities are really
Yeah, there will definitely be plenty of opportunities, plenty of jobs. There'll be some cross training opportunities for people in new jobs in the industry as well. So I'm in love with the technology, extremely excited about it. I think it's amazing. I'm looking forward to working with you guys to help us build some affordable homes. We're going to build some ADUs as well, and some other structures. So we're very excited, and I want to thank you for taking time out of your busy schedule to spend some time with me to discuss 3D printing. It's always good speaking with you. Thanks for listening to the CDC Experience. This is our monthly podcast. I'd like to thank my guest Fernando Paolillo with ProBuild. Once again, I'm Will Crawford, and I will see you in the community.